Basic rigging. MSHA Regulations. S77.210 Hoisting of materials. Hitches and slings used to hoist materials shall be suitable for handling the type of materials being hoisted. Men shall stay clear of hoisted loads. Taglines shall be attached to hoisted materials that require steadying or guidance. 56 or 57.16007 Taglines, hitches, and slings. Taglines shall be attached to loads that may require steadying or guidance while suspended. Hitches and slings used to hoist materials shall be suitable for the particular material handled. 56/57.16009 Suspended loads. Persons shall stay clear of suspended loads. Tools of rigging. Hoists, cranes, slings, special lifting devices. Hoists and cranes. Different types of hoisting equipment. Manual and powered devices. Underhung and top-running cranes. Monorails. Various types of jig cranes. Slings. Main purpose is to suspend a load from a hoist. Commonly made of wire rope or welded link chain. Can be constructed from fiber rope, synthetic webbing or metal mesh. Most slings are assembled by sling manufacturers. Can be assembled at the job site. The rigging system. Load. Sling. Hoisting equipment. Rigger, designer and operator of the system. Is equal to single, complex rigging system. The rigger must apply intelligence, common sense, and experience. Anticipate what will happen when the load is moved. Thought process must take place before the work is started. Questions that must be answered by rigger. What is to be done with the load? What tools are needed? Do the tools have the capacity to handle the loads and forces involved? How can the hookup be made? What will happen when the load is first moved? What will be the travel path of the load to reach the desired location? How will the load be set down at the desired location? What other factors are involved? Weather, electrical wires, sloping grades, visibility. Are additional personnel needed to control the load safely during the process? Planning a rigging system. Determine the weight of the load. Locating the center of gravity of a load. Distinguishing the force components, horizontal and vertical, at work in a diagonal force, loads at some angles other than 90 degrees to the horizontal. Limitations of each component of the rigging system. Determining the weight of the load. Shipping paper. Manufacturer's information attached to the load. Catalogs or blueprints. Tables of weights from manufacturers or handbooks. Make sure the weight has not changed. Volume and area formulas. Calculating an allowable load. Determine the breaking strength of the rope. Load which will cause the rope to break. Refer to standard tables in rigging handbooks. Listed according to the diameter and kind of rope. Design or safety factor usually 5. Find the load limit by dividing the breaking strength of the rope by the design factor. Example, if the table indicates that the breaking strength of the rope you are using is 27,000 pounds, dividing this figure by the design factor of 5 gives you a 5,400 pound maximum allowable load. Determine the center of gravity. The point at which the load will balance. Whole weight of the load is considered concentrated at this balance point. When suspended from a point, the load tends to move so that the center of gravity is directly below the point of support. Make sure the center of gravity is located directly below the hoisting hook. Stable load. Balanced about its center of gravity. Directly below the hoisting hook. Unstable load. Has a tendency to tip or topple. Creates a hazard to personnel and equipment. Before lifting any load, check for hazards. If not directly below the hook, the load is unstable. If the sling is free to slide across the hook, the center of gravity will shift directly below the hook. If two slings are used, one will assume the greater share of the load. The sling must not be attached to the load at a point lower than the load's center of gravity. Exception to this rule when lifting loads on pallets or skids. Then apex of sling must be above the center of gravity. Determining the center of gravity. Marked on the load by manufacturer. Located in catalogs or blueprints. Some objects have lifting lugs. Calculate or estimate it. Make an educated guess and correct through trial and error before making the lift. Procedures to determine center of gravity. Connect slings and hoist based on estimate of object's center of gravity. Take up slack in slings or hoist. Lift the load just enough to check stability. If stable, continue to lift. If unstable, lower load and adjust the rigging. Lift point should be moved closer to end that dips. Repeat until load is stable. Horizontal force. Very often sling legs are attached at an angle less than 90 degrees. Then a horizontal force is added to the vertical force. Resulting combined force is greater than the weight of the load. Horizontal force increases as the angle becomes smaller. When a sling angle is 30 degrees, the total force is twice that of the load. Sling angle of 45 degrees are not recommended. Horizontal forces act on the load, causing damage by compression or buckling. Horizontal forces are absorbed by using a spreader beam, making the sling legs between beam and load vertical. Sling components. Hooks. Coupling links. Fittings. Sling legs. Can be assembled at the job site but must use recommended components and assembly procedures. May also require some sort of weight test. Hook hazards. Attachments should never be field welded to a hook. Heat should not be applied in an attempt to reshape a hook. Can reduce strength of hook. Could result in hook failure at loads lower than the rated load. If handles or attachments are required, they should be obtained from the hook manufacturer. Purpose of a latch. Purpose is to retain slings in the hook. Not intended to support the load. Should be sturdy enough to retain the sling if the moving load should catch on something. Latches are used to close the throat opening. Must be provided on hoist and crane hooks. Reasons for removing a hook from service. Hook throat has increased by more than 15%. Wear exceeds 10% of the original hook section dimension, or there is a bend or twist of more than 10% from the plane of the unbent hook. Hook shows cracks, excessive nicks, or gouges. Factors affecting wire rope strength. 3 major signs of loss of strength. Flat spots worn on outer wires. Broken wires. Reduction of rope diameter. Other factors that can reduce strength. Bending the rope over a curved surface. Temperature. Corrosion and environment. Rope fittings or terminations. Bending the rope over a curved surface. Normal curved surfaces that ropes are curved over include sheaves, pins and other curved surfaces. The rope is subjected to bending stress. Reduces rope efficiency nominal strength by a certain percentage. Efficiency depends upon the capital D is equal to diameter of curved surface. Small d is equal to nominal diameter of rope. Example. Fiber core 6 times 37 wire rope 1 inch in diameter, small d. Sheave with a 30 diameter, capital D. Capital D, small d ratio is 30:1. Efficiency is 95%. Load rating dropped 95% from 83,600 pounds to 79,420 pounds. Wire rope clips. To basic designs. Use section contacts dead end of the rope. Tends to crush some wires. Affects strength if U-bolt clip is installed wrong. Fist grip can be installed either way. Use only forged steel for lifting slings. Removal from service. Rope distortion such as kinking, crushing, unstranding, birdcaging or core protrusion. Heat damage from any source. Look for damage from weld and weld splatter. Cracked or deformed end fittings, hooks particularly. Corrosive failure of one wire adjacent to end fitting. One broken or cut strand. Pitting due to corrosion. For single wire rope either. 10 broken wires in a section the length of one rope lay. 5 broken wires in one strand within a distance of one rope lay. Chain hazards. Similar force acts on the links if the chain is knotted or twisted. Never shorten a sling by twisting or knotting. Never use bolts and nuts or other fasteners to shorten a sling. Thank you.